next speaker is Madeleine Noland. Madeleine received her Bachelor of Music in Music Education from the University of Massachusetts in 1989. Madeleine began her career in the television industry with a startup company called Back Channel Media. In early 2013, Madeleine joined LG Electronics as a consultant member of LG's ATSC 3.0 team. She serves in several leadership roles within the ATSC 3.0 process. She is chair of S34, dealing with the presentation layers, as well as vice chair of S31 and chair of S33-3. Ms. Noland was the 2016 recipient of the prestigious ATSC Lechner Award for her leadership roles related to the development of the ATSC 3.0 Next Generation Broadcast Television Suite of Standards. Madeleine.
Thanks very much, Wayne, and thanks to you all. I know this might be the last bit of thing that you're planning to do, at least today, so I appreciate your attention. And thanks also to Skip, Luke, and Rich for learning more every time I hear these things. So back to the protocol stack diagram that we've been looking at for a while. The applications and presentation layer that I'm going to talk about kind of gets into where the consumer sees all of the good stuff that Luke and Rich have described. What is the fruit that we're going to bear here with all this underpinnings? So this gets into pictures and sound, of course, and the software, meaning the interactive applications. And in the pictures and sound, we've got ultra high definition plus, which we'll get into as well, immersive audio, personalized audio, interchangeable closed captions, all sorts of stuff. And with the applications, a wide variety of things that broadcasters can do, part of which is the dynamic ad insertion that Rich talked about, and there are many, many other applications as well. S34 is divvied up into a bunch of different subgroups, ad hoc groups, each working on an individual part of the process. And the one in the middle there, conceptual models, is something that I'm going to talk about first. If anybody is a software or an engineer or other type of engineer and you get a pile of requirements from some kind of commercial or business person, it just says, can you please make this go? And then at some point someone has to break that down and say, well, what really are we building here? And so some of the conceptual models were used to develop from the requirements into something the ad hoc groups could start to work on. So I want to get into that first briefly. Starting with the status of the document, so Skip put up at the beginning the big caveat that says this is a work in progress, but I do want to show you what we've got going. We have our video standard, which is currently an HEVC video standard. That's a candidate standard. We have our audio, which is in 3 parts, and that's a proposed standard at the moment. And we have captions and subtitles, which is a full completed standard. And lastly, we have the interactive content, which is currently at candidate standard, and our disclaimer at the bottom that says, by the way, these things are going to change. The ones that are candidate standards could change, as well as the proposed standard. So types of services, Rich was getting into this. What are we enabling broadcasters to do? Certainly linear services, we can still watch TV, but we can do more with watching TV now. We've got multiple alternative components and apps. We can also do some on-demand services. This includes both via broadcast as well as via broadband. And we can do interactive applications, some of which might be riding on top of an AV service, and some of which might be the starting point for your service. So for example, you might have an interactive application which is a gateway to your video on demand offerings on the internet. And lastly, of course, you can have audio-only services, and there's one other that's not on this list because it's not so much consumer-facing, but you can have data-only services. And again, coming back to the bootstrap that Luke talked about, broadcasters can now send something that has nothing to do with television. As long as the bootstrap is there, it can tell the receiver this is the kind of information that you're going to get here. You can send something completely different, like an entire software update to a wide range of devices or whatever it is that people want to send. So a little bit about the service components, now getting back into the world of television. We have obviously audio, video captions, applications, and other types of data files. And getting into the multiple alternative components, there's different ways to do this. You might have one where you're supposed to select one component. For example, you're probably not going to choose more than one audio track to run at the same time, although there are exceptions to that, believe it or not. You might want to select more than one component. For example, you might have a main view and a picture-in-picture, so you're having two videos. And these things might be user selectable, or they might be auto-selectable. So for example, if the receiver is not capable of Ultra HD, it might be choosing an HD video path. And again, hybrid delivery, which was talked about before, we have broadcast-only services. All the signaling, all the components, everything delivered by a terrestrial. Or you could have hybrid services where some components and signaling are delivered by broadcast and others by broadband, and the receiver is in charge of combining and synchronizing those. We also have the concept of broadband handoff capabilities. So if you are moving in the fast train or the car or whatever you're doing, and you fade into an area where the RF reception fades just a little bit, you could actually be transitioning to entirely broadband reception and then transition back into broadcast reception as you re-enter a strong signal area. One thing about this is that you, of course, do have what we would call pure over-the-top services, which are available today. With ATSC 3.0, we're only focused on the things that at least have a starting point or some element in the broadcast, the over-the-air broadcast. But interestingly, you can have an over-the-air broadcast that consists of nothing but signaling that points to broadband where everything else is. So it's a very flexible system. This is the same chart that Skip showed earlier, again with certain things coming over broadband and certain things coming over broadcast. And in this case, you might be making some selections in your house. You might be choosing the main video, or you might be choosing a secondary audio, or in other cases, you might be choosing some closed caption tracks and some applications. And all these things can be either selected by the viewer or by the receiver according to the type of choice to be made. So getting into the video. What is ATSC 3.0 going to allow you to do with video? We actually carved it up into 3 chunks. We do know that there's a lot of legacy SD content out there, and you will be able to send that. Believe it or not, there was a very long discussion about that. Hey, this is not a backwards compatible system. What do I have to do legacy SD for? Well, I have a library full of it, so let's let that go. We also have legacy interlaced HD. We have progressive HD, and we have progressive UHD, and we kind of lump those two together because those two are where some of the newer bells and whistles can come on board, whereas the others really are considered to be legacy formats. Yes, you can send what you've got, but please don't make any more of it. So getting into that, the progressive HD and UHD content can have the wide color gamut, high dynamic range, scalable coding, high frame rate. Legacy SD and interlaced HD can't use these enhancements, but they are available to the newer content. And as Luke was pointing out, just because we have a physical layer that can deal with different screens, well, we probably should have video that can deal with different screens. So definitely targeting small screens and big screens. Also enabling the multiple videos delivered via broadcast, broadband, or both. And this is different from ATSC, where Rich was making the comparisons between 1.0 and 3.0. In 1.0, you get this many videos per service. In 3.0, you get as many videos per service as you can stuff down your pipe, and plus extra ones that you could send over broadband. And we do have support for 3D. And it uses HEVC. So Luke talked about how your new physical layer gives you 25 megabits per second, whereas the old one was 19.39, which is, I think, 30%-ish increase, which was the baseline. Basically, everybody looked at Luke and the team and said, if you can't give us 30% more, don't bother, because it's not backwards compatible, we won't do it. So by God, they got 30% come hell or high water, and they did. When you layer on top of that HEVC video encoding, which I think one of the other speakers pointed out, Skip did, this is 2 generations after what we have with 1.0, you have some real bandwidth savings, being able to go from MPEG-2 TS video to HEVC plus the extra bits that you get in the physical layer. A little bit about spatial resolution. We are looking at 3840 by 2160 as the high point right now. We also have these video formats, which I just suggested, and they are defined by the content type. And we have spatial scalability included, the SHVC. I know that there's a lot of skepticism out there in terms of whether scalable coding is really going to work this time, really. And I think there's a lot of optimism, and it is in the standard as an optional operating point for broadcasters. One of the nice things about SHVC is that you could potentially construct your stream with a base layer HD, which is sent in a very robust physical layer pipe, and it's intended to reach indoor receivers and mobile devices and all sorts of things. And then you could have an enhancement layer which has the Ultra HD bits, and that could be sent less robust. And so if you haven't got the rooftop antenna or the high-powered reception, you can still get the HD picture and it will be beautiful. Speaking for myself and Sony and our other CE manufacturer colleagues, we do a nice job of spatial resolution upscaling. So the point being that you can have your service with an HD base layer intended for mobile and difficult reception. You can have an Ultra HD enhancement layer, and for those receivers that can get it, to build it all together into your UHD signal. A little bit about frame rates. We really tried to put fractional frame rates to bed, but it can't be done. We're working on it. Maybe in the next generation, maybe our children and grandchildren will finally get rid of fractional frame rates. But we need it for legacy. So 24, 30, 60, and 120, integer and fractional. And being an international standard, certainly 25, 50, and 100, integer only. And the frame rates are restricted by region, as you would expect. Please don't send 60 hertz in a 50 hertz region. You might not like your results. And the high frame rate is really allocated again to the progressive formats, the HD, UHD progressive. We also have temporal sublayering, again for backwards compatibility and or for efficient use of your bits and your robustness. So you can send a base layer, for example, of a 60 hertz picture, and you can send the other half of the pictures in an enhancement layer. Dynamic range and color. This is the subject of many discussions that are ongoing. In essence, with dynamic range, and I'm about 3 days ahead, I think, of what's public by putting this up here, but we do have standard dynamic range and 2 high dynamic range transfer functions, the PQ and the HLG transfer function, and that will be public in a few days. Probably would have been public before now, except for people who are at CES and don't have time to get all this stuff done. We have optional static metadata for PQ, which is identified in SMPTE 2086. So this is the metadata that says what the mastering display was. And then we also have the constant light luminance data points of max fall and max CLL. You put those 3 together, and it's commonly known as HDR10. With this metadata, that means you get 1 set of metadata per program. So what was the monitor that this program was graded on, and what is the highest pixel? What is the light of the highest pixel, and what is the average? We're also talking about additional HDR-related metadata technologies, such as dynamic metadata, and that would be giving you information about the picture on a frame-by-frame basis rather than a program-by-program basis. So color. We have wide color gamut, BT 2020 it's commonly known as, also captured, of course, in BT 2100. And we're allowing that for either SDR or HDR content. And then we have narrow color gamut BT 709, which is restricted to SDR. I don't think that anybody is planning on putting out HDR content with BT 709 color, but if you were, don't do it in ATSC 3, because we really would prefer not. Okay. And color representation, YCBCR, which we all know and love, and additional proposals are in active discussion right now. Audio. So we have immersive audio, high spatial resolution, essentially speakers or sound coming from the ceiling. So you might have at one point had mono. That was my home stereo. When I was growing up, I had a turntable with 1 speaker, and I had an amplifier that I could heat my room with. It was great. And then you have stereo, where you've got your 2 speakers, and then surround sound, where you've got it in a single plane, basically around your ear height. And what the immersive audio does is it adds overhead sound. So if you can get your entire family to agree to hang 22 speakers in your living room, some of which from the ceiling, that's great. We can allow you to do that. Or you can only just 4 on the ceiling. Can we please have just 4? But we also have technology where you can have speakers that are ear height that actually point at the ceiling and will reflect sound down. The coolest thing about this, if anybody has ever heard immersive audio in headphones, you will be stunned. What you can hear in headphones compared to what you can hear with 22 speakers surrounding your head, which certainly makes sense because you only have 2 inputs. So theoretically, we can do everything with 2 inputs, and they can. It's amazing. Also personalization. So this is another big piece of it. We have alternate audio tracks, special commentary, video description, all kinds of selectable components, normalization of loudness, of course, contouring of dynamic range. The Column Act stuff is all available and possible. And again, targeted to various devices and various speaker setups plus headphones. Plus we have the 2 systems that have been selected, AC4 or MPEG-H. It's regionalized, so the expectation is that a country or region will choose one of the 2. And these are very advanced compression algorithms, and I'll show you some of the advantages that provides. So channels and objects, I think you guys probably are familiar with this. Channels are what we all know and love, portions of an audio track designated for a particular speaker location. The new systems also have these things called objects, which are elements of the audio track, and they can be rendered by different speakers at different times and volumes and identified separately from the rest of the audio mix. So for example, you might want to simulate a sound moving around the listener, so you have this object which is moving from speaker to speaker at different volumes. Or you might want to isolate a personalization track. This is actually very important for the hearing impaired to be able to crank up the dialogue period and turn all the music and effects and everything else down so that they can actually hear what's being said. And what we use is dynamic metadata to inform the renderer of how all these objects are to be presented. So a little bit about compression. This is a set of examples. This is an example of how you might put together your audio. So you've got 192 bits, for example, allocated to your music and effects. And then you might have English-Spanish dialogue as separate objects. And then you might have an English DVS, which is the digital video description service, so that you can explain to those who are seeing impaired, you can explain to them what is on the screen. You could do that in English and in Spanish, and then you'll have some metadata. So you can see all these different programs that I might have. If I'm the viewer and I'm there at my receiver choosing what I want to hear, I might be listening to English complete main. I might be listening to the English with the DVS, and I have my 2 choices in Spanish as well. With ATSC 1.0, one single complete main at 384 kilobits plus kilobytes plus one ancillary track at 192 kilobytes is 596 kilobytes of your bandwidth. With ATSC 3, you can have all these 4 representations for the low price of 384 kilobytes, which is going to make your video guys happy because they get more. Speaker placement. So what do we want? Well, do we want, you know, the man cave with speakers everywhere, or do we want the romantic living room? But the good thing is that the metadata allows the rendering to be customized to the user's sound system. So you can have a smart AV receiver that either allows you to manually input, or the really smart ones have mics in the room that can tell you exactly, that know where everything is. And we use that information to make sure that each speaker has the right volume in order to get the immersive experience that was intended by the content producer. And as I was saying, it works for headphones too. Truly amazing. And getting into accessibility, we have services for the visually impaired and the hearing impaired. The descriptive video service, which I mentioned before, is the manner of describing the main events that are going on the screen. And we also have the oral version of the emergency alert crawls, so that if you put a crawl on the bottom that says there's a tornado coming, people can hear it as well as see it. And then for the hearing impaired, we have closed captions, we have a dialogue boost, and we have closed signing, which is actually under development. Closed signing is kind of an interesting one, which we'll get into. So for the visually impaired, we have the VDS track, which is possible. And we have the oral emergency alert. With ATSC 1.0, it required a separate complete track. So, and only 2 tracks were allowed. We had regular and we had SAP, which is the secondary audio. So SAP had to be used for everything. So you might have Spanish audio going on in your SAP channel, and then the minute you have to put in an emergency, the Spanish gets overridden by the emergency speaking, which is probably going to be in English, so you know it doesn't help the Spanish listeners very much. So the SAP channel had to do double and triple duty. In ATSC 3.0, you can have as many of these things as you want, and so you don't have to double up on the on the SAP channel. And you can choose whether you want to listen to VDS or EA, and you also do not need to send complete audio twice. You can send the music and effects once, and the VDS can be writing as its own object. On the hearing impaired side, we have the captions. This is based on IMSC1, excuse me, a little acronym dyslexia there. And it's also sent as a separate track, which is kind of a new thing. It used to be buried in the video, and now we have it as a separate track, which allows a number of different things to happen. Perhaps you want to take that and you want to put it into a printer, or perhaps you want to take that and do all sorts of different things. So having it as its own track enables different things to happen down the road. We have the concept of dialogue boost. We have ways of doing that cleverly with, even if you have the dialogue and the music and the effects all in one mix. There's some pretty neat algorithms that allow you to do some dialogue boost. But when you have the dialogue as a completely separate object, now you can really control it very, very well. Both the viewer can control it and have degrees of control, as well as the receiver can do some work with that too. Closed signing. So if you wanted to provide American Sign Language, and one of the things that I learned in this project is that if you are born deaf, the first language you learn is American Sign Language. You do not learn to read English. And you think about, how were you taught to read English? Well, A is for apple, and C is for cat, and all of this. And you know that the ah sound looks like an A, and that's in father, and cat, and da-da-da-da. People who are born deaf, they have no association of these letters with these sounds that then make up words. And so American Sign Language is their native language. And the ability to be able to send American Sign Language is very interesting. In the past, of course, it would have to be burned into the video, so everybody has to look at it. But if you're able to send it as a picture-in-picture, you can send it as a quote-unquote closed sign language, like closed captions, and the viewer can turn it on and off as needed. Currently, ATSC is exploring that. We obviously have picture-in-picture capability already, so you can certainly do it. But we're looking for feedback from the community on exactly how big should the closed sign language box be, and should there be constraints. You need to be able to see the hands, the face, the body, you know, all of these different things. So we are doing outreach to the community to provide some, I guess I would call it constraints on a picture-in-picture to optimize it for closed signing. A little bit about captions, the IMSC1. Why are we doing that instead of the Happy CTA 708608? First of all, it's worldwide. It also supports image glyphs, so if you want to send Chinese characters or Korean characters or anything like that, you can. It supports the FCC requirements. And it's considered safe harbor for IP-delivered content, and since we're a hybrid system, we want our caption system to be very similar to that of the internet. Hence the last bullet. One other thing about captions that I want to mention is that the requirement is that you send it as IMSC1. You may optionally also send it as CTA 608 or 708 in the video stream if you want to. And that's sometimes very useful for legacy receivers or for your MVPD partners downstream that might not be using IMSC1 just yet, but we think that's going to be the future. Interactivity, this is the fun part. So specifying interactive application environment to enable interoperability and all the good stuff that people can dream up. So this is a new thing. It's based on W3C technologies. So again, looking at the hybrid environment, if you are a broadcaster and you have your digital team that's busy writing applications and whatnot for your digital platform, and this way, in the world of TV, when you say it's the digital platform, you mean your computer, your internet-based stuff. That's becoming a bit of a misnomer, but that's the way it's been talked about. If you wrote an app for the web, then you don't need to tweak it very much to make it work in this environment. And it adds TV-centric functions to the W3C web technology. So for example, the W3C doesn't need to define an API for changing the channel because there's no such thing on the internet, but this one needs to have that. So other things like checking the parental control setting, do I really want to display this app or do I not? Is this a TVMA app or is it a TVG app? Access the personal devices, access the devices PVR, And also, the other thing that these apps need to be able to do is respond to time events. And this gets back into sync, what Rich is talking about. If a goal is scored, you don't want the little celebration graphic to show up 5 minutes later. You want to show it right now. So ways to get a timed event into the program with the application. What can you do? Well, you can do all sorts of stuff. Draw some graphics. You know, this is your toolbox. So whatever you want to do pretty much is going to work. I guess the thing that you have to remember is that TV platforms are not computers, so they don't have really big CPUs, so you can't do everything. But you can do a large number of things. Ad swapping is one of them. So some examples. As I was mentioning, you can send that data at the right moment and goal. Okay. I've always offered a beer to anybody who can identify this movie. No one has won the beer yet. Those of you who've seen it before are not eligible. Nobody knows. Nobody wants a beer. Okay, creation of the humanoids. It's not copyrighted anymore. That's why it's up here, so I can use it in my slides. But, you know, do you want to play the director's cut ending? And this is, again, where it gets into the PLPs that Luke is talking about and ideas for broadcasters. You don't have to have, okay, I'm a multicasting broadcaster. I have 3 services. That's this many, always and forever. With ATSC 3.0, you can say, well, right now I got 3 services, but for the next hour and a half, I'm going to use 4 services, and then I'm going to take it back down again. So I've got my group that's watching the baseball game, which has gone into extra innings, and then I have everybody who just tuned in to watch Judge Judy, and they don't give a hoot about the baseball game, but you have those who are watching the baseball game that really do give a hoot because it's now in extra innings. And so you can perhaps put something up that says, hey, you want to finish the baseball game or are you here to watch Judge Judy? And they can pick which one. You just went from 3 services to 4, and as soon as the baseball game is over, you're back down to 3. So these are the kinds of flexibilities that this system offers. Picture in picture. Maybe you're not interested in what this chef is doing, but you are very interested in what that chef is doing. And you could perhaps toggle between which one is the main view and which one is the picture-in-picture view. So in summary, there's a lot you can do. New service types, new business models, new pictures, new sound, more accessibility options, and the flexible web-like interactivity that's available. And the other thing I think, which Skip talked about at the very beginning, is the expandable standard. If the FCC only rules on the bootstrap, then you can do lots of things with the rest of the system. And as Luke pointed out, all those little arrows between the boxes at the very beginning of this slide was showing you how each layer is independent of the other, and they can be swapped out independently. So if you decide you wanted to put in a different video or audio codec, you can signal that. If you can even switch out the entire transport system without having to redo the entire physical air system. So the point of expandability and flexibility is key. And with that, I think I'll turn it back over to Wayne. Thank you.
Panasonic.